Hey guys, Survival here, and today I want to go over whether 3D printers are a prepper's tool. So there's going to be three things that I want to go over. First of all, does 3D printing have a place or relevance to prepping, bushcraft and survival? What additive manufacturing technology is best suited, and what are the capabilities of the resulting 3D printed parts? So, in relation to this topic here, of whether it has a place or relevance, well, in relation to this first topic, whether it has a place or relevance, I would tend to say for bushcraft, no. Why? Well, my logic is as follows. Bushcraft is your ability to turn what nature provides into something you need to help your situation, to help you affect your survival, and to give yourself that sense of luxury whilst you're out and about in the bush, using minimal things you've brought with you. So I would definitely say no. However, in relation to survival, I would say yes. However, I would have that conditional to being bugged in. Why? Well, survival could be away from your place of residence. It could be away from your bug out location. It could be out in the bush. However, if you have bugged in, you are likely going to have access to all the facilities you require to operate a 3D printer. However, when it comes to prepping, I would say the following, maybe, with some question marks. Now you're probably thinking, but hey, if you reckon it could help your survival if you're bugged in, why would you question it for prepping? Well, it comes down to a few things. First of all, and I would actually apply this to every single point here, and that is, are you or one of your group a mechanical engineer? I would further say, do you have access to proper 3D CAD software which doesn't require internet licensing? And if your answer to those two questions is no, then it's not really going to help you. Because whilst you can model up something basic, and whilst you can print things that have been made by others, if you need to develop something yourself, and you need to test it, and you need to have a good understanding of the constraints that you have to work within, if you're not a mechanical engineer, you're not really going to have the background. And this leads me to a third question. And that's actually an offshoot of, are you or one of your group a mechanical engineer? And that is, do you have finite element analysis software, also known as FEA software? This software allows you to run structural analysis on a 3D model. And it is essential because it will show you weaknesses in your design, and it will also show you where you've over-engineered your design. So, unfortunately, this whole is there a place or relevance to 3D printing in prepping, bushcraft and survival? It's extremely subjective when it comes down to survival or prepping. Bushcraft, it's very clear. However, there are a lot of constraints. That said, if you do have a mechanical engineer in your group, be that you or someone else in your group, you have proper 3D CAD software that doesn't require a connection to the internet to run, you have access to finite element analysis software so you can test it, then by all means, yes, 3D printing is relevant to prepping, and it can be relevant to survival for the same reasons. So, in regards to why or what the relevance is. So, just extend another branch here on the mind map. So for relevance, subheaded by prepping, we can produce things such as clips, we can produce hooks, we can produce snap clips. Now what I mean by snap clips are the type which you usually have on backpack straps, you know, where there's the two tabs that you push in and it releases. Providing you have the appropriate materials and you've got the correct model or are able to model it, you can actually produce parts that have what is effectively a plastic hinge. In other words, a hinge which is made of the same material as a part, but has a kind of springiness to it. However, you do have to watch. It can fatigue a lot faster. What's another great one you can do? Well, another great one, funnels. You can make custom funnels that suit certain containers you have. So let's say you've got a good tub which you like to keep your cereal in to keep the air out, or to minimize the air that's with it. Well, if it's got a broad opening and you find it can sometimes be a little unwieldy, then you can actually 3D print a funnel for it. Let's say, for example, you have an oddly shaped water container. And when I say oddly shaped, I'm talking about the opening. So you can't just chuck the hose over it and fill it without water going anywhere. You can make a custom funnel for it. One thing I've actually found to be very handy is to actually model up and print a funnel that screws onto the end of a soft drink bottle, allowing you to store rice in a washed out soft drink bottle. It can be very handy. Another thing also, when it comes to organization, you can print a whole bunch of little storage tubs. And you might be thinking, hey, I can just buy some much larger storage tubs. Well, there's one important thing to keep in mind, and that is the storage tubs I'm talking about, you can make slot together, thus allowing you to have multiple storage tubs that you can just slot together. You can pick them all up in one go. No need to grab multiple separate containers. Now, whilst this might seem an odd or stupid idea, it can actually be very handy, especially when you're looking after things such as small components. Really it comes down to whatever you need to store that is small by slotting them together. If you need to separate one to hand it to someone, just slide it off. But otherwise, you've got them all there. Another great thing you can do, and this is especially relevant to prepping, and that is cable management clips. You can find heaps of these all over the internet, which you can download the model of and print yourself. Some of them allow you to adjust according to the number of cables you need to manage, or you could very simply create your own. Cable management is essential. If you want to prep properly and you want to have a properly organized setup, cable management is essential. Being able to go, hey, this cable's a problem, I need to replace it. It goes from here, through here, and over to there, without having to try and guess what cable it is extremely useful. It'll save you a lot of time, a lot of stress, and a lot of annoyance. Good cable management is like proper planning and preparation. It keeps you on track, it saves you time, and it saves headaches. And really, it ends up as being the sky being the limit. You know, whatever you can think of. You're only limited by you or your group's imagination. And that's actually one of the wonderful things about 3D printing. Providing you have someone who actually does have an engineering background and can operate the 3D printer, can test the parts to make sure they'll work, you actually get a whole world of possibilities opened up to you. So I'll just link this over here to prepping, just to try and make things a bit easier for everyone, because I will be making this mind map available, most likely in a PDF form. That way you can review it. And feel free to print out a copy and annotate it, expand it, adjust how you see fit. This is just here to help you. This isn't the be all end all. but Bushcraft and I figured this would be a good thing to go over. So, this brings us to the next question. Which technology is best suited? Well, I'll quickly go over these. So, FDM, that is extruded filament. So, it's what they call filament deposition modeling. And it uses an extruded filament. It's the most common type of 3D printing around. And depending on the type of printer you've got and depending on the quality of it, that will determine how good or bad the parts it can produce are. Now, there is another one here called SLS. Now, this one's one that people haven't really heard of all that much, but it's called selective laser sintering. It uses powdered plastic. So, what happens is there's a powder of very finely ground plastic, and a laser will come over and melt the plastic into place where the part is being formed. The workbed will lower, a roller will bring another layer of plastic across, and the laser will once again melt the plastic. Now, this can allow extremely high resolution. However, it is limited by how fine or coarse the powder actually is, and further by the intensity or lack of the laser involved. Now, DMLS is effectively the same, except instead of using plastic, it actually uses powdered metal. And once again, it can have extremely high resolution. However, that is limited by the grain size. Just bringing these out, as you can see, there are a few commonly shared properties. Now, this one here, SLA, this technology is called stereolithography. This is actually what I would personally consider to be one of the most exciting 3D printing technologies around. It is extremely effective, extremely high resolution, and it's rapidly advancing all the time. So, stereolithography uses a photopolymer resin, which is cured by a laser. This allows for extremely high resolution, limited primarily by the resin's mechanical properties and the quality of the laser curing the resin. So this can go anywhere from 50 microns in terms of how thick the layers are, as well as feature size, all the way down to quite commonly 25 microns. Now that is usually the layer thickness. However, it is actually quite commonly the smallest feature size that can also be produced on a part being printed using this method. So the other thing that is really amazing about this technology is that these photopolymer resins, they come in multiple types. So there are standard, so clear or coloured. Then there's what I personally really find absolutely amazing, and that is tough resin. Then there's flexible resin. So the tough resin is used for things like clips, snaps, and other parts such as a thick chain, for example. Really anything that's going to be commonly used as an end-use part. The flexible resin, that's really great for prototyping things like drink bottles. Whilst not food grade, it allows you to prototype them. It also lets you print, for example, wheels or rubberized pads that could be used on, be it a drone or even just, a toy car or something else like that. Basically, get some, experiment with it, and you'll know what the flexible resin can do. It does vary between different manufacturers and on different machines, and that's why I would definitely say, if you are able to get into these technologies, and if you do have someone with an engineering background, do get hold of some stuff while you can and experiment. Find out whether you think that, well, certain resins are worth looking into or not. But as I said, it's price prohibitive, and you do need an engineer as part of your team. The other thing that is really amazing is some companies have actually started to introduce a ceramic resin. And what this is a resin which you 3D print, and once it's been post-cured, that's actually one other thing I wanted to point out, and that is all resins require post-curing. So this is a very important thing to note, and that is with SLA printing, because a resin is used, parts once printed have to go through what's referred to as an IPA bath. So what this is isopropyl alcohol, also known as rubbing alcohol. You put the parts into 100% rubbing alcohol. You give them an agitation period, which will be the information for which will be provided by the resin manufacturer, and then there will be a period which you let them sit for. Once again, resin manufacturers will provide this information. What this does is gets rid of any excess resin, cleaning off the parts. You then let them air dry to evaporate any remaining rubbing alcohol. Once that's happened, then you've got to post-cure the parts under a UV light. So why do you need to use this post-cure with light? Well, you effectively have a UV laser which is curing the resin very quickly to form the part. However, whilst it does cure the resin, it doesn't fully cure it. So to get the best mechanical properties out of the final part, you do need to post-cure using a UV light. Now, as I'm sure you can tell, whilst this technology is by far the most advancing and the most broad and useful one, providing you have someone on your team who has a background in mechanical engineering, there is a lot more involved in the process, and as I'm sure you guessed, it will cost a lot more in order to run. So if I was looking at a 3D printer for my prepping, now I would first of all say, well, we've got a guy who's a mechanical engineer on our team, and what's our budget? So my advice would be, forget about DMLS, not really worth it, too expensive. It's really left at the moment to industry only, as it's still very much a developing technology. SLS, I would still argue it is too expensive, industry only, primarily due to the fact that it's never really become all that a commercial technology. It's still very much the price of a decent brand new car. So you're talking $40,000 to $50,000 for a good quality machine plus materials. So this really leaves us with the two primary 3D printing methods that I personally have experienced and used, and that is FDM and SLA. So FDM, whilst common and uses extruded filament, it does have limitations. So the primary limitation is layer adhesion. So what we mean by this is, as the part is built up by laying down multiple layers of plastic which stick together, this results in an inherent weakness in the printed part, and that is how well and how strong the bond between layers is. So you definitely have to look at the orientation you're going to print the part in, making sure that it is printable in that orientation, and as a result, that will also limit you to what you can and can't print. So that is something to keep in mind. But the reason I mention FDM is it will print most things you need. Weight is very much an issue. FDM parts primarily do not handle a lot of weight. However, providing you don't need to subject them to a lot of weight, it can work extremely well. But that is one thing to keep in mind. The benefit, however, is you can get these machines across all price ranges. So you can get all these kit machines, which you can order online, and they can be a couple $100, or depending on what certain technology shops near you stock, you may be able to buy complete pre-assembled machines for closer towards $1,000 or just over. And then you can go into industrial quality ones, which have what's known as a dissolvable support material, formerly known in industry as HIPS, high impact polystyrene, which dissolves in a detergent bath. So really, FDM, it can be very beneficial, it can be very handy. I mean, having a dissolvable support material is amazing, because you can then print fully assembled parts and simply dissolve the support material out, as long as you've left enough holes for the support material to drain through. So that actually takes a lot of inherent weaknesses that are in existence purely because certain parts need to clip or thread together. So that is another thing to keep in mind. So I'll just chuck that in here. However, I will make a note here that that is industrial machines only. However, industrial FDM machines can be found anywhere between $15,000 to $20,000. So industrial machines are a lot more affordable than an industrial machine of any other printing technology. So we look at what I would personally recommend for a group where money is not really an issue, or even if you do have to combine your funds to be able to afford a good machine. If your group is actually big enough or are willing to do it, and you do have a mechanical engineer in your group, definitely look at investing in a stereolithography machine, an SLA 3D printer, because being able to print in resin, it can be an extremely amazing thing, and it opens up a lot of different options. So first and foremost, layers are not an issue. As it is a resin which is cured by a laser, you get complete adhesion at every layer. You don't have to worry about a bead of plastic being pushed down hard enough onto the previous one in order to get a proper fusion and good layer strength. Layer strength is not an issue with SLA printing. What is, however, an issue is both the resin used for the intended purpose as well as your post-processing. So in other words, don't leave it in the IPA bath too long. If you leave it in the bath too long, you will actually start to eat away at the part, weakening the printed part. And your post-curing under the light, if you over-cure it, you will make it brittle. And finally, one other part about it is you must use a UV blocking spray. So once you've post-cured your part, to prevent further curing and to prevent over-curing, you need to apply a UV blocking spray. Now, you can get plenty of clear coat plastic-friendly paints. That's what I would recommend. A light spray, let it dry. it'll give it UV protection, it'll leave it visible as whatever you had it as, be it coloured or clear resin, and it will prevent it from over-curing. These machines can be found from anywhere between $3,000 up to as much as really you're willing to pay. The one thing I do say, however, is if someone in your group is a mechanical engineer, by all means look at it. Otherwise, I would definitely say to avoid it. And the reason I say this is, if you don't have someone who is a mechanical engineer, then I would be very cautious in getting into SLA, because you do need to use FEA software. You do need someone who's got a good knowledge of CAD software, but primarily who has a good knowledge of materials. And the reason being, you don't really have one set fixed choice of material, which you do with FDM. You know, most filaments you get are going to be ABS or PLA. You know, mechanically, they're fairly similar. I mean, ABS is stronger for certain applications. However, there's really a choice between one or two. There is no purpose-based selection as far as I have seen. Whereas when you look at SLS, DMLS, yes, you can get various plastics and various metals. However, DMLS is just so expensive, it's not even really worth looking into. I only mentioned it as it is something worth knowing about. And in regards to SLS, well, yes, there are different plastics available. However, the range is not all that big, and where you do actually get the big range of plastics is on your extremely expensive machines. That's why I've connected it to, with this arrow here, to the too expensive industry only bubble. Because unfortunately, when a machine's going to cost easily $30,000 or more, that puts it out of the reach of pretty much all of us except for a very select handful. If you do have a mechanical engineering background and you are able to select the correct resin for the correct end use, then I would highly recommend go for SLA. You know, an SLA printer in the hands of a good quality, competent mechanical engineer with a good knowledge of their materials, you can produce almost anything. And the amazing thing is, because you're only limited by the resin, a lot of companies that actually produce both SLA printers and resins are constantly developing new and better resins, giving you more options. There is, for example, I know of a high temp resin, and what that is when fully post-cured, a part will be able to withstand very high temperatures in the many hundreds of degrees, such as a nozzle on a blowtorch. So being able to 3D print something that can withstand high temperatures and the likes can be very handy. So to be honest, what I probably would say from this whole discussion is that the capabilities will only be limited by the materials and the skill of your mechanical engineer. So I would actually hazard to say that 3D printers are a good preppers tool, conditional to having a good mechanical engineer in your team. So if you guys have any questions, chuck them down below this video. We'll do our best to answer as many of them as possible, and I will neaten this mind map up and I will make it available in one form or another. It'll most likely be a PDF file. And yeah, if you guys have any questions, feel free to ask. I'm happy to make any recommendations or refer you to further information, such as websites, of 3D printed manufacturers for certain technologies. Unfortunately, DMLS, there's not too much for it, so I probably won't get too involved into explaining or referring people to manufacturers' websites for that. However, if you do ask, I will provide you the information, but just remember I will not go into too much detail about it. However, FDM, SLA, SLS, ask a question, I'll do my best to answer it. And just one other thing I want to mention. I do have a background in a proper formal university degree in mechanical engineering. However, it doesn't mean that I'm up to date on absolutely everything. The area of additive manufacturing, also referred to as 3D printing, is changing at such a fast rate that people like myself, who are mechanical engineers, who are passionate about 3D printing, aren't always able to keep absolutely up to date. So I will do my best to provide you all the information that you ask for and to address any questions or concerns you have. I do, however, apologise if I miss something out, or in the event that I may get something wrong. At the end of the day, I'm only human. I'll give it my best. So I hope you guys enjoyed this little discussion, and I know there's a lot to take in, a lot of things to consider. I may add a few more little points and links and maybe a few other things to consider to this mind map. But yeah, I do recommend having a 3D printer as part of your prepping equipment. It is an awesome prepper's tool, at least for the here and now, whilst you're prepping. Even if you can't run it once the SHTF has happened, you at least still are able to use it and benefit from it in the here and now while you're preparing. However, as you can see here, in this bubble I've got selected, I do say that conditional to you either being or having a person in your group who is a mechanical engineer. Now, I do understand and I do accept that a lot of people either are unable to attend uni because in some parts of the world there are financial constraints. However, yes, you can actually learn enough. There are enough recommendations that people can give you that you can kind of wing it. However, when you really start pushing the boundaries on designing your own parts that are specifically intended for end use, you do really need to learn how to both design parts but also how to test them using finite element analysis. And this brings me to one last point that I do want to make, and that is, with finite element analysis, remember the following, and that is garbage in equals garbage out. What I mean by this is that if you put incorrect data in, you will get incorrect results. FEA does not double check. It assumes you have told it the correct parameters from the get-go. You know, that the file that you're testing, the 3D model, is of the correct scale. You know, that it's in the systems units, that the materials are in the correct units and the properties are correct. It is assuming that you have constrained it properly. You do have to be very careful using FEA software. If you get it wrong, it could go very wrong. Because the software, it has no double checks or triple checks. It will simply solve and tell you what the go is based on what you tell it. And this is the other reason why I say this is all conditional to you having a good mechanical engineer in your team. A good mechanical engineer will be able to spot these things. They'll have a good knowledge of materials, they'll have a good knowledge of how to use FEA software and CAD software, and they'll be able to spot just by looking at the results. Without even having to read the actual numbers, they'll be able to tell, does this even look right? And one of the most important things you can ever do when designing anything is know approximately what the results should look like. Now, whilst I understand you can't always, just go, oh, hey, it should be exactly this, it should look like exactly that, and, just be able to work it out in your head. Whilst I know that that's not possible, you should at least know what approximately it looks like. For example, if you're looking at something like a hook, you should know where you're going to find the highest concentration of stress. So if your FEA software shows that point where you would expect stress to be as being under no load or no stress, then you know something is wrong. Unfortunately, unless you've had a lot of practical experience where you've physically tested things, measured things, you've then experimented with the software and looked at it, you're not really going to know these, what these things should approximately be unless you do have that background in mechanical engineering. And why would I say that? Well, it comes down to the fact that whilst mechanical engineers haven't seen everything, they see a lot, but they also understand the forces involved mathematically, and it allows us to approximate what we should expect. So, for example, if you've got a 10 kilo bag, you simply multiply that by 9.81, which is gravity, to get it in newtons. Now that's the force in newtons that your hook, for example, has to be able to hold. So now we know just by looking at that, so, we know exactly how much actually needs, how much force actually needs to be on there. So we go, hey, well, 10 times 9.81, well, we're going to just multiply that out. What do we get? 98.1 newtons. So we go, well, it's going to be approximately 10 tens are 100 because we round up, because rounding up is safe when you're looking for what the maximum force is going to be, because you want to test for a force bigger than what you're actually going to experience. Because if you overstate it, you start to get towards what's called a factor of safety. So personally, I would round that to 100. I would then look at some basic rules. So a few basic rules of mechanical engineering are factors of safety. Now, the absolutely most basic is we have a factor of safety of anywhere between 4 and 6 for static loads. In other words, something like a bookshelf where it sits in place and you put a book on it and the book itself is just sitting there. So when I say a factor of safety of 4 to 6, that is the maximum permissible force multiplied that many times, and that resulting number is how much force the shelf has to be able to withstand before critically failing. So I would then, for the sake of this little example, I would take that 100, multiply it by 5, split the difference on the factor of safety, just to keep the numbers simple and easy to work with. So that is 500 newtons, which is half a kilonewton. And that's what you need to look at making sure it can support. If, however, the part is going to be under what is called a cyclic load, in other words, something like a chair, where you're going to sit on it, get up, sit on it, get up. Whilst this might seem like an impractical example, because, I'm going to sit on a chair, I'm going to be there, well, you're not going to be sitting perfectly still. You're going to be moving. So it's effectively a live load. We refer to it as a cyclic load. Commonly, the factor of safety we use for cyclic loads will vary between 8 to 12. Never less than 8, but it can go up as much as you like. These rules are approximations which have been worked out through trial and error over time, through calculations, and the thing to remember is these rules set the minimum. You know, if you want to make something safe and money is not really a concern, increase your factor of safety. It'll increase the durability of the part. Because if you make a part that can hold, for example, 100 kilos, but it only needs to hold 10, that part will be a lot stronger than a part that can just hold 10. However, you have to look at the trade-off. Is it going to cost me more to produce it for my purposes than it's ever going to be worth? So if I needed a part, and this is just what I personally would do, that can hold 10 kilos, I would design it to hold 60 kilos, because I would personally apply initially a roundup of force and then a factor of safety of 6, resulting in a part that can hold significantly more material, significantly more weight, using significantly more material. And that, however, would be for a static load, not a cyclic load. Now, I'm only mentioning these factors of safety as approximates. These are something that you need a person who is highly experienced, a person with a proper formal background in mechanical engineering to know. 3D printers, they are a prepper's tool. However, you're going to need to have a good mechanical engineer in your team. And I'll just put a proviso here, or a little note here. They need a good knowledge of factors of safety, and for that of static and cyclic loads. So I hope this has been informative. Feel free to leave any questions down below. I'll do my best to answer them. And remember, stay safe in the bush.